In the previous class, we have discussed examples on Fourier series. In today's class, we'll discuss examples on half range Fourier series. So we have half range cosine Fourier series and half range sine Fourier series if it is defined in the interval 0 to pi. So f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos nx, where a naught is equal to 2 by pi integration from 0 to pi f of x dx, a n is equal to 2 by pi integration from 0 to pi f of x cos nx dx. Similarly, sine series, if it is defined in the interval 0 to pi, so f of x is equal to summation n is equal to 1 to infinity bn sine nx, where bn is equal to 2 by pi integration from 0 to pi f of x sine nx dx. If an interval, if it is defined other than this 0 to pi, means arbitrary interval, so we have half range Fourier cosine series f of x is equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos n pi x divided by L, and where a naught is equal to 2 by L integration from 0 to L f of x dx, and a n is equal to 2 by L 0 to integration from 0 to L f of x cos n pi x by L dx. Similarly, Fourier half range Fourier sine series, if it is defined in the interval 0 to L, means arbitrary interval, f of x is equal to integration from f of x is equal to summation from n is equal to 1 to infinity bn sine n pi x divided by L, where bn is equal to 2 by L integration from 0 to L f of x into sine n pi x by L dx. So with this, so we'll solve example. So today's first example, already we have discussed this type of examples. Show that the sine half range series for the function f of x is equal to Lx minus x square, and x is lies between 0 to L, is 8L square by pi cube divide pi cube into summation of n is equal to 0 to infinity 1 upon 2n plus 1 raised to 3 into sine 2n plus 1 divided by L by x. Means we have a function f of x as a Lx minus x square, and interval is 0 to L because x is lies between 0 to L. We need to find or we need to show sine half range Fourier series for this function is 8L square divided by pi cube summation n is equal to 0 to infinity 1 upon 2n plus 1 raised to 3 sine 2n plus 1 divided by L into pi x, right? So first you write down the formula. So x lies between 0 to L, means it is an arbitrary interval. So we have half range Fourier series, half range sine Fourier series. If it is defined in the interval 0 to L, so it is given by f of x is equal to summation n is equal to 1 to infinity bn sine n pi x by L. So we need to find here bn. So we have bn is equal to 2 by L integration from 0 to L f of x sine n pi x by L dx, right? So here bn is equal to 2 by L integration from 0 to L. So in this interval, a function is Lx minus x square. It is given into sine n pi x divided by L dx. So observe this one. So it is a product of two functions. We need to integrate. So for that, we need to apply Bernoulli's rule, integration by parts. So first function is u and second function is v. So we have a Bernoulli's rule. So apply that one. So bn is equal to 2 by L, Lx minus x square. This is as it is, and integration of sine is minus cos n pi x divided by L whole divided by n pi by L, minus derivative of this Lx minus x square is L minus 2x. Differentiation of Lx is L, differentiation of x square is 2x. So L minus 2x. Integration of this minus cos n pi x divided by L will be minus sine n pi x by L divided by n pi by L, and one more this n pi by L. So you'll get this as minus n pi by minus sine n pi x divided by L whole divided by n pi by L raised to 2 plus derivative of this L minus 2x is minus 2 because L is constant. So derivative of this constant is 0 into integration of minus sign n pi x by L is cos n pi x divided by L whole divided by n pi by L raised to 3, and derivative of this minus 2 is 0. 0 into something is 0. So next terms you will get 0. So limits varies from 0 to L. Now, so here, in place of this x, substitute upper limit. Upper limit is L and lower limit is 0. L into L is L square minus L square means upper limit you will get this as 0. 0 into something is 0. And lower limit in place of x you substitute 0. 0 minus 0 is 0. 0 into something is 0 means by substituting L and upper limit as L and lower limit as 0. So you'll get this term as 0. Now I'll take advantage of this sine function and limits as 0 to L. So substitute upper limit, L get cancels, sine n pi 0, right? And substitute lower limit in place of x 0, sine 0 is 0 for both upper and lower. So you'll get this as 0. So these two are 0. Only thing is in this you substitute upper and lower limit. So plus into minus is minus. Plus into minus is what here? Minus, right? This 2 by L is as it is minus 2 into 1 divided by n pi divided by L raised to 3. So taking reciprocal, you'll get this as L cube divided by n cube pi cube into cos n pi x divided by L. Limits varies from 0 to L. Now substitute upper and lower limit. 2 into 2 is 4 with the negative sign minus 4. 1L get cancels with this L cube. So you'll get L square divided by n cube pi cube. This is as it is. In place of x you substitute L and in place of x you substitute 0. Substituting upper limit as L get cancels. So cos n pi minus lower limit as 0 cos 0, right? Now minus 4 L square divided by n cube pi cube into cos n pi is minus 1 raised to n minus cos 0 is 1. Now multiply this negative sign to this. Minus into minus is plus. Minus into plus is minus. Taking positive term as first, you will get this as Bn is equal to 4L square divided by n cube pi cube into 1 minus minus 1 raised to n. Now substitute in half range sine Fourier series. So f of x is equal to 4L square divided by pi cube into summation n is equal to 1 to infinity 1 upon n cube 1 minus minus 1 raised to n into sine n pi x by L. But 1 minus minus 1 raised to n. So this is equal to 0 when n is even and this is equal to 2 when n is odd. So we can write this as f of x is equal to 4L square divided by pi cube summation n is equal to considering only odd terms because even terms 1 minus minus 1 raised to n is 0. So consider only odd terms. N is equal to 1, 3, 5 so on and you will get this as 2 divided 1 minus minus 1 raised to n is 2. So 2 divided by n cube into sine n pi x divided by L. Now f of x is equal to 4 into 2 is 8. 8 L square divided by pi cube. Summation n is equal to 1, 3, 5 so on up to infinity. 1 upon n cube sine n pi x divided by L. But so we can write this odd numbers as in general 2n plus 1. Always we take for even numbers 2n. 2n plus 1 will be what here? Odd number. So where n is equal to 0, 1, 2, 3 so on. Thus we have 8L square divided by pi cube. Summation n is equal to 0 to infinity. In place of this n you replace 2n plus 1 raised to 3 because by 2n plus 1 raised to 3 into sine 2n plus 1 divided by L pi x because so this 2n plus 1 so what it indicates, so this is a odd number. What it indicates, this is a odd number. 2n is even and 2n plus 1 is odd number, right? So substitute n is equal to 0, so this will be 0, so you will get this as a 1 cube. 1 cube is 1 means it is a odd number, right? Similarly, you substitute 1, 2 plus 1 is 3. Again, it is a odd number. Substitute 2, 4 plus 1 is a 5. Again, it is a odd number, right? So this is required answer. So this is one of the important example. Now show that L by 2 minus x is equal to L divided by pi. Summation n is equal to 1 to infinity 1 by n. Sine sine 2n pi x divided by L. X lies between 0 to L. Here function is not given, so we need to find first what is f of x, right? So interval will be what here? X is lies between 0 to L, means this is a half range series. X lies between 0 to L means this is a half range series. Next, whether it is cosine or sine, how to find? So see here, we have a sine term. So this sine term indicates this is half range sine series. This is a half range Fourier sine series, right? Next, we need to identify what is f of x, right? So from the given data, so what we have by definition, half range Fourier sine series. So f of x is equal to summation n is equal to 1 to infinity bn sine n by x divided by L. So this will be the half range sine Fourier series. So in place of f of x, what we have here? L by 2 minus x, means our f of x is L by 2 minus x, right? Now we need to find bn and substitute bn, so you'll get the required series. Now bn is equal to 2 by L, integration from 0 to L, f of x sine n by x by L dx. So bn is equal to 2 by L. So f of x is L by 2 minus x sine n by x by L dx, right? Now 2 by L, this is as it is. So observe, again it is a product of two functions. Apply Bernoulli's rule, integration by parts. So first function is u and second function is v. So keep first function as it is, L by 2 minus x, and integrate second function. Integration of the sine is minus cos n pi x divided by L whole divided by n pi by L, and derivative of this L by 2 minus x will be minus 1, because L by L is like a constant. Derivative of constant is 0. 0 minus 1 is minus 1, and integration of this minus cos n pi x divided by L will be minus sine n pi x divided by L divided by n pi by L, and we have already one n pi by L, so you'll get this as a square. And derivative of this minus 1 is 0. 0 into something is 0. So next terms you will get this as a 0. Limits varies from 0 to L. Now substitute limits. This 2 by L is as it is. Take this negative sign outside and take reciprocal of this. So L divided by n pi. 1 divided by n pi by L will be L divided by n pi. L by 2 minus x cos n pi x by L, limits varies from 0 to L, because substitute upper and lower limit to this sine function. Take advantage of this sine function. Substitute upper limit as L. L get cancelled. Sine n pi 0. Lower limit as 0. Sine 0 is 0. Both upper and lower limit, you will get this term as a 0. Now left is this, substitute upper and lower limit. Both L get cancels. The numerator and denominator, minus 2 divided by n pi. Substitute in place of x L. L by 2 minus L. Take LCM and simplify, minus L by 2. And in place of x you substitute L. L get cancels, cos n pi, minus in place of x you substitute 0, L by 2, and here you substitute 0, cos 0. Cos 0 is 1. 0 into L by 2 is L by 2. Now Pn is equal to minus 2 divided by n by 2, and both the terms we can take minus L by 2 outside. So common, take it outside, minus L by 2 into left is cos n pi plus 1. So 2 get cancels, minus into minus is plus. Bn is equal to L divided by n pi. I'll take this one as both are positive. I'll take this one as a first term, 1 plus, and cos n pi is minus 1 raised to n. Now Substitute this in half range sine Fourier series. So f of x is equal to L divided by pi. Summation n is equal to 1 to infinity 1 by n, 1 plus minus 1 raised to n sine n pi x by L. But 1 plus minus 1 raised to n. So this is equal to 0 when n is odd. Right. So odd multiples minus 1 into odd numbers will be what here? Minus 1 you will get. 1 minus 1 means 0. And even numbers you will get plus 1, means multiply this minus 1 even times you will get plus 1. 1 plus 1 will be 2. So 1 plus minus 1 raised to n is 0 when n is odd, and 1 plus minus 1 raised to n is 2 when n is even. Now substitute f of x is equal to L by pi, summation n is equal to 246 up to infinity 2 by n, 1 plus minus 1 raised to n is 2 for even values of n into sine n pi x by L. But in general, we can write this 2 get is equal to 1 for n is equal to 1, 2, 3, so on. For n is equal to 1, 2, 3, so on. And hence we can write the series by replacing n by 2n in the form. Once again, I'll explain this one. So because of this network problem. So, but here n is equal, f of x is equal to L by pi, summation n is equal to 246 up to infinity, 2 by n sine n pi x by L. Why it is 2? Because 1 plus minus 1 raised to n is 2 when n is even, and this is 0 when n is odd. So 2 by n varies from 246 to infinity. But 2, 4, 6, 8 or 8 so on. So we can 2, 4, 6, 8 so on. So we can write in general this as a 2n, because n, whether it is even or odd, this is multiplied with even number. It is even n, if n is even or odd, it is multiplied with the 2, so you'll get even number only, where n is equal to 1, 2, 3, so on. And hence we can write the series by replacing n by 2n in the form. So f of x is equal to L by pi, summation n is equal to 1 to infinity 1 by n sine 2n pi x divided by L. So f of x is L by 2 minus x. This is equal to L by pi, summation n is equal to 1 to infinity 1 by n sine 2n pi x divided by L. Why we got this as a 1 by n? Because 2 divided by 2n. We need to replace n as a 2n. 2 divided by 2n. 2 to get cancels. You'll get this as a 1 by n. So this will be the required answer. Right, one more example we'll discuss. Obtain the Fourier sine half range series for the function f of x is equal to 1 by 4 minus x. X lies between 0 to 1 by 2, and x minus 3 by 4, x lies between 1 by 2 to 1. Right? Now, f of x is defined in the interval 0 to 1, because starting point is 0, ending point is 1. So defined with the f of x is defined in the interval 0 to 1. So compare this with 0 to L, half range Fourier series. Compare this with 0 to L. So L is equal to 1. So f of x is equal to summation n is equal to 1 to infinity bn sine n pi x, because L is 1. Now bn is equal to 2 by 1, because L is 1, integration from 0 to 1 f of x sine n pi x, because L is 1. Now 0 to 1, this interval, this is divided into two sub intervals. 0 to 1 by 2, function is 1 by 4 minus x. 1 by 2 to 1, function is x minus 3 by 4. So substitute. So Bn, this is equal to 2 into integration from 0 to 1 by 2 f of x sine n pi x dx plus integration from 1 by 2 to 1 f of x sine n pi x dx. In this interval 0 to 1 by 2, function is 1 by 4 minus x sine n pi x dx plus 1 by 2 to 1. In this interval, function is x minus 3 by 4 sine n pi x dx. Now apply Bernoulli's rule, integration by parts. This 2 is as it is, 1 by 4 minus x. Integration of sine n pi x is minus cos n pi x divided by n pi minus derivative of this 1 by 4 minus x is minus 1, and integration of this is minus sine n pi x divided by n pi raised to 2. Limits varies from 0 to 1 by 2 because derivative of this constant is 0. 0 into something is 0. Next terms you'll get this as a 0. Now similarly, x minus 3 by 4, integration of this sine is minus cos n pi x divided by n pi minus derivative of this x minus 3 by 4 is 1. Integration of this is minus sine n pi x divided by n pi raised to 2. Limits varies from 1 by 2 to 1 because derivative of this 1 is 0. 0 into something is 0. Next terms you'll get this as a 0. Now take separately limits for each term. So 2 into minus 1 upon n pi, you take it outside, 1 by 4 minus x cos n pi x, limits 0 to 1 by 2, this one. And this minus into minus is plus, plus into minus is minus 1 upon n square pi square sine n pi x, limits varies from 0 to 1 by 2 minus. Why? Because this minus this plus is minus 1 upon n pi x minus 3 by 4 cos n pi x, limits 1 by 2 to 1 plus 1 divided by n square pi square sine n pi x 1 by 2 to 1. Now substitute limit 2 into minus 1 upon n pi minus, in place of x substitute 1 by 2 minus 1 by 4 cos n pi by 2 minus lower limit as 0. We'll get this as a 1 by 4 because cos 0 is 1. 1 upon n square pi square sine n pi by 2 minus 0. And similarly, substituting limits for this upper minus lower, 1 upon n pi 1 by 4 cos n pi minus of minus 1 by 4 cos n pi by 2 plus 1 upon n square pi square 0 minus sine n pi by 2. Now why? Because sine 0 is 0, cos n pi is 0. So this is equal to 2 minus 1 upon n pi minus 1 by 4 cos n pi by 2 minus 1 by 4 plus 1 by 4 cos n pi plus 1 by 4 cos n pi by 2. Both plus and minus get cancels. Minus 2 divided by n square pi square sine n pi by 2. So 2 into 1 upon 4 n pi. This minus 1 upon n pi and this minus 1 upon n pi, right? And take this 1 by 4 common for both the terms. You'll get this as 1 minus cos n pi outside minus 2 divided by n square pi square sine n pi by 2. So this 2 ones are 2 twos are, multiply 2 to each term, both the terms. So 1 upon 2 n pi, 1 minus minus 1 raised to n minus 2 into 2 is 4 divided by n square pi square sine n pi by 2. Thus sine half range Fourier series is given by f of x is equal to summation n is equal to 1 to infinity. Bn is 1 upon 2 n pi, 1 minus minus 1 raised to n minus 4 divided by n square pi square sine n pi by 2 into sine n pi by x. So one of the very important example many times appears in the question paper, right? So I'll explain this simplification again. How we got this 1 minus cos 2n or cos n pi as. So here these two get cancels, plus and minus. So left with what here? Minus 1 by 4 plus 1 by 4 cos n pi. So take minus 1 by 4 as a common. So this minus 1 by 4 and this minus 1 upon n pi, minus into minus is plus 1 upon 4 n pi. And minus 1 by 4 outside means 1, and here minus 1 by 4 outside means a plus sign is there, so you'll get minus cos n pi, right? And rest is multiply this 2 to this this and this term. So multiplying 2 to this, 2 ones are 2 twos are 1 upon 2 n pi, 1 minus cos n pi is minus 1 raised to n, minus 2 into 2 is 4 divided by n square pi square sin n pi by 2. Now substitute this in half range sine Fourier series. So you will get the required answer, right? So today I'll stop here only. So thank you everyone.